All right, recording. All right, welcome to Ionic Utah meetup. And my name is Todd Hale, and we're hosted by MTech. I want to put in a good word for MTech. They've got great programs, not just in web-related development. They've got actually a native Apple programmer program, as well as digital design and some marketing, and then boom, off into the health sciences, nursing, and yeah, good. They're kicking off a QA program, and tons of trades, culinary, automotive repair. I have one son that graduated from the automotive tech, and he's a mechanic down in Orem, loving it. My daughter went through the cosmetology program, and she's got her own studio up in South Jordan, and so I have a lot of great things to say about MTech. So I want to thank them for hosting it here and giving us access to the services and everything. And then for Ionic, they're also sponsoring this. They're paying for the food that you're eating, and of course they've got the framework. They keep that up to give us the tools we need to build cool apps and PWAs, and we'll be learning about those kind of things. So yeah, let's turn the time over to Brett. Quick introduction, and then jump in.
Yeah, great to be here. This is going to be a little bit of a different. Sorry, I have to do my bifocal thing so I can see you and then read this. So you get older, you need reading glasses. So this is going to be a little bit different than our normal Ionic presentations, because what I wanted to present is an Ionic application and then using a continuous integration and continuous deployment pipeline in AWS. This is an application I've wanted to do for a while, and so we started on this early in this year, and Claire's helping me with that. And we also have another developer that's working with us. So it's a 3-person team. It's a kind of a small team, and for what we're going to demo, it's probably overkill for what this application needs, but it's an area that I like to work in. So that's what we want to present. Oh, we're way ahead on the slides here. Hang on. I will. I've got that here. Yeah, so I'm an independent software consultant. I work for myself. I contract largely with the state of Utah, but I do a lot of DevOps stuff. So my background is in electrical engineering, and then I went into software development and worked with Todd at Novell for years. And we were in a QA department, so that's where this presentation is going to talk a lot about testing, which I think is an important topic that's often overlooked by developers. I also am one of the organizers for Salt Lake City DevOps Days, and we have a monthly meetup for DevOps. If you're interested in DevOps, we meet once a month on the second Wednesday of the month, and you'll see us on Meetup where that schedule is. You also find me on LinkedIn and on my website. So we talked about, I'll just give a brief introduction on the application. So this is a business application written in Ionic using Angular with a Nest.js backend and a Mongo database. We'll talk a little bit about that. So the front end is Ionic based. We use, it's a business application to manage crews. So landscaping crews specifically. A lot of the work done now is all on paper, where they write things down, both in English and Spanish, and then invoicing customers is a long, laborious process, and we're trying to modernize that. So Ionic's the perfect fit for that. So we use the latest Ionic 6.3. We also use Capacitor for some of the plugins. 2 specific plugins. We use the camera to take pictures, and we also use voice detect to capture. So for landscape workers who just want to talk into it, they could just talk and record the voice. What also integrates, we won't go into this too much, but maybe in future presentations, we integrate into a CRM as customer relationship management tool. It's a common business tool for sales. Oh, yeah.
Is the voice text like plug it?
Yeah. Yeah, just the basic one that comes with it. And we use a CRM to communicate with our customers. So it has a lot of features like sending out text messages and flows to social media and stuff like that. So rather than write that ourselves, we just integrate into the CRM. So here's some just basic screenshots. It's a pretty simple application. We manage member lists, which are like our customers. You can see we have like a list view of different customers. We have a basic CRUD operations where you can edit the customer, update it, capture communication, and that also then is integrated into the CRM. So on our sales side, we'd know, oh, okay, we know here are the customers, here's what we've done, and what the last communications were. Some of that's still in development, but that's the goal. Then the key part is the work order. So we have a work order screen and a list of the different work orders we capture of what work was done. So here's like the list view, and then you might add it to a member. You take some images of work that was done. And then when it's complete, we'll send a text message back to the customer saying work's been completed. And they can also follow up with like feedback to our crews and to our owners. So the application backend, we decided to use a Nest.js framework. I'm a big framework person. I don't like reinventing the wheel. So my background is in Java. So there's a lot of large legacy frameworks like Spring and stuff that are very popular. And Nest.js came out a few years ago. It's a great framework, similar, so you can still write in JavaScript or TypeScript, but it gives you a lot of the boilerplate stuff that you do on the back end without having to write it yourself. It's open source. It has secure authentication, so we use like a JWT implementation for authentication. Has a lot of middleware solutions, controllers, providers, pipes, and guards that you would expect in an enterprise type application. And it supports both REST and GraphQL APIs. And we opted to use GraphQL. One is because we integrate with lots of different systems. GraphQL seemed to be a better fit. Also, I'd done a lot of REST APIs. I kind of wanted to learn GraphQL. So this application actually does both. Authentication is REST, but integration into the application and Mongo is all done through GraphQL. Okay, the database, we use a Mongo database, open source. Nest.js by default, that's its de facto database. If you've used, probably most of you there, Ionic, use Mongo or other NoSQL databases like Firebase or CouchDB. Mongo is very popular with single page web applications. And if you own their stock a few years ago, you did really well. So, and I've been we use Mongo in my work up in Salt Lake and been very happy with it. We use their managed solution. It's a great database. If you're not familiar, if you've done relational databases, NoSQL databases are quite different. So data is stored in JSON objects, key value pairs, which is, fits in well with JavaScript. Documents are stored in collections instead of tables. And the fields in the documents can change. So for developers that like their models to change quite a bit, it's very flexible. Of course, that always comes at a trade-off when your application needs to know about that. It has limited transaction support. So I do a lot of enterprise development, and they are really set. Their relational databases have been around since the 70s, and they love transactions. But transactions come with some limitations, performance specifically. So Mongo, when it was created, didn't support transactions out of the box and did kind of instead of deleting or locking stuff, would just overwrite and do versioning of documents. So it's very fast, depending on how you if you index it correctly. So I'll try to hurry up on some of these slides here. So we'll talk about the infrastructure. So we use Docker containers to package all of our components. I know there's serverless technologies like Lambda that a lot of people use. I really like Docker because it's a consistent way to package, whether you're doing Mongo, the middleware, or the front end. You package it all the same. You put it in containers. So Docker was a big win for people that if you're in the operations and deploying applications. So Docker contains all the libraries you need to run the application and gives you a consistent runtime environment. And where they're really beneficial is deployment and scaling. So it's like, I tell my kids, it's like having a CD, which people don't know DVDs and CDs anymore, but you used to burn images, right? And then you wouldn't change them. If you want something, you just burn a new image. That's what you do with applications. Then we also use Kubernetes, and we use Amazon's Kubernetes. It's called EKS. It's their Elastic Cloud Kubernetes service. It's their offering of Kubernetes. We create Kubernetes, and everything we do in AWS, we use code to create. So we use Terraform. We won't talk about that today, but that's another great technology. And all the components are deployed in EKS. We'll talk a little bit about the benefits of that. So if you've probably heard of Kubernetes, Kubernetes was originally created by Google. It's how they scaled all their services in their cloud. It was called Borg, and they open sourced it, and it's now maintained by the Cloud Native Computing Foundation. There are alternatives, like Amazon has Elastic Container Service, which is a simpler service. Azure has something similar, but the de facto standard really is Kubernetes. It's what most companies are using. I would guess if you looked around and looked at most of any of the companies here that are here along the Wasatch Front, they're all running Kubernetes. Just some of the basics of Kubernetes. So Kubernetes consists of nodes, which are like the physical machines or virtual machines that are maintained in the cluster that's managed by Kubernetes. And then pods are the smallest deployable unit of compute on Kubernetes. So we usually just talk about nodes and pods. And specifically, if you're an application developer, you're talking about pods. And pods are distributed across the nodes. So that's how they do their scaling. That's how they do their reliability. And then containers, those Docker containers, run in these pods. And you can have multiple containers per pod, but typically you'll put one container per pod and then organize your application like that. So some of the benefits of Kubernetes, declarative configuration. That's the key part, where you specify in YAML files in a manifest exactly what your application, what services are available, how they scale, what determines their health, how much CPU memory, and then Kubernetes manages that whole life cycle for that pod. They provide networking, security, monitoring. All that is so much easier in a Kubernetes environment. And it automatically adapts to different load conditions. So if you have, let's say it's the holidays and you need to scale up, you can just specify what the load should be, and it just handles it overnight. And then at night, it might scale back down to a minimal amount. Large Kubernetes clusters can support thousands of services. And I would guess most of the companies here, that's what they use. And they have like Weave and some of these companies do fantastic things in Kubernetes. Some of the drawbacks of Kubernetes, like I said, in this demo, probably this application, it's way overkill for what we have, but and cluster can be complicated to set up. It's also more expensive to run, and like for this application, we could probably run it much cheaper in an ECS solution or some kind of Lambda type thing, but so less beneficial for small applications. Okay, here's a kind of a high level of our infrastructure. We have we have our one Kubernetes cluster, and in that Kubernetes cluster, we support multiple environments and separate those with namespaces. So that's one benefit of Kubernetes. You could set up multiple clusters, but to save costs, we just use one cluster and have a test, staging, and prod environment. And then our build environment that we're going to demo here, we use Bitbucket and Bitbucket pipelines. And in that build process, tests are run. And then if the test pass and image is produced, it's pushed to ECR. That's where there's a repository for containers, kind of like Docker Hub. And then then we deploy from there, and Kubernetes pulls automatically from ECR. Okay, Clara, we'll turn time over to Clara now.
Do I need to turn my mic on?
No. Does she need mic on?
Just the audio, inside of Zoom.
Oh, okay. Okay. So my name is Clara DeLynn, and I attended the University of Utah for 3 years in their honors program, and I studied a lot of different things, but I wasn't sure what I wanted to do. And I ended up dropping out and getting back into coding. I first coded when I was 14 through Khan Academy. I learned how to animate, and that was like my introduction to coding. But more recently, I've learned web development. I went to Dev Mountain boot camp that was 6 weeks and intensive, and I really enjoyed that. And now I'm a test and QA automation intern for Brett, and I also am a digital media manager and specialist for someone named Stephen Hassan.
Hey Claire, can you just share your screen?
Oh, yes. Thank you for reminding me. Okay. Okay. So I'm going to be talking to you about automated testing, which is something that I do in my job. So first, I'm going to talk about unit testing. What we use in our application is called Jasmine, and it helps to ensure the quality and functionality of individual units of our code that are called components. And a reason why unit testing is really important is that it helps you catch bugs a lot earlier in your code and maintain good quality. And some of the things that you can do with Jasmine are define test suites, organize test cases, and perform assertions to validate expected behavior. So for example, one thing that we did for an assertion was when a user logs in, if they have an incorrect username, then what I have done in one of my tests is making sure that if you type in a wrong username, that a pop-up comes up and tells you that you have the wrong username. And then the next part of testing that I actually do is integration testing end-to-end, and we use Playwright. And this kind of testing looks at how different parts of a system all work together. And Playwright is really cool because you can simulate real user interactions, which I'll talk about in 2 slides more about how that works and looks. But it allows you to test the complete flow of your application, exactly how a user sees it, which is pretty cool. It also allows you to utilize multiple browsers for cross-browser testing, so you can make sure that your application runs on both like Safari and Chrome. And then you can also take advantage of a provided API for testing more complex scenarios. This is a diagram of manual testing. This is more of a traditional graph because more recently, software engineers have started to use more end-to-end tests and have realized how important they are. So it looks more like a rectangle now. But yeah, and then some of the benefits of Playwright are that it's backed by Microsoft, which is a really reputable company. So it's regularly coming out with new updates and bug fixes and new features. And it works really smoothly. One of my favorite things about Playwright is the web application recording feature. So you can, while it's recording, you navigate your app just as a user, and it records all actions that the user does, which is really nice. It makes writing tests a lot easier, and it will also capture important information such as page element selectors and event listeners, so you know exactly how to write the test and do the different things that you want to do. Okay, so now I'm going to do a demo of our app, and I'm going to show you a little bit of what it looks like. So this is one of the tests that I've written. It's a CRUD test, which is create, read, and update, but it doesn't have the delete on it. And basically the test has like an overall name. You can make a before hook. So in this test, before each different test, it goes to the login page, logs in, and then makes sure that the URL says that it's on the home page, because that means that I logged in. And then so it has a test where it creates a new member without required answers, which is what I was talking about with the assertion. And so for each page of the website, you make a separate page. So this is for the home page, the add member page, the edit member page, but there are a lot more on the left side, but I'm just going to show you this one test as an example. And so in the add member page, home page, the different pages, you can create, I don't know what they're called. Do you know what they're called? Yeah. Okay, yeah. You can create page objects to do the different actions that you want to do. And and also up here in the constructors, it references the different parts of the page and how to find them. So that's where the recording is really nice, because you might not be sure how to get to, like, click on a certain part of your application, but the recorder will tell you what role it is and how to call it by the name. So one thing that is really cool that our app also uses is something that helps create random data, which is kind of cool too. And so now I'm going to try running the test. So I'm going to show you, because it pulls up in another browser. This is Chromium. And when you run a test, you go over to the side, and so I'm going to run the CRUD test.
This is because of video plugin, but Playwright.
Yes. So as you can see, that one just went in and it didn't put in all the information, and it checked to make sure that something came up. And all of the information that is going in, I'm using from what is it called? Oh, it's here. ng-neat falso. It's really cool. You can customize the different variables. So for example, I needed the state to be an abbreviation, and it has that, or you can customize different numbers or different things that they say, which is very cool. Anyway.
It's basically a paper.js, and it kind of is not maintained, and just like that. It's really nice to manage data.
Mm-hmm. Yeah. Okay. Oh yeah. Also, for example, this is one of the customizations you can do if your app doesn't know how to deal with accents, and like, because if you are searching for a name and it doesn't have an accent, that could be a problem. So here in the random generator, it doesn't have names with accents, which is good. That like makes sure that there aren't problems. But eventually you will need to. Yes, but that was an example. You can like pick how long they are too. And then, okay, back to the presentation. Okay, so the next thing that I'm going to talk about is our continuous integration and continuous deployment pipelines. Continuous integration helps to make sure that while code is changing very frequently, it's being tested right after. And we're using Nest.js for that. It's a powerful and scalable framework for building server-side applications, and it's TypeScript based, and it can be integrated with other CI tools to automate the testing process. So this is just a little diagram of what continuous integration means, where it goes from the developer to source control and then the build, and then you test it and report back, and it goes around in the circle. And then continuous deployment takes continuous integration a step further by automating the release and deployment of software changes. And it uses the pipelines to build, test, and deploy the applications automatically. So as soon as the changes happen, you can test it right after. And this helps so that teams can release new features and bug fixes rapidly, making there be shorter release cycles, and it's faster for your app to be put on the market and be ready to be used by your user. And this is just a diagram of what a release pipeline looks like. So on the left, you have continuous integration, and then you have continuous delivery, and then continuous deployment. And now, is it your turn again?
Yeah, so we'll just, this is a terrible diagram, so I'll describe it since it's.
So this is our pipeline. I'll describe it. It looks like a electrical diagram, so we'll go over it. But our process that we use is, so when Clara or myself or a developer does it, we work at a feature branch, and then we're going to check that in to the feature branch. And then the process is that then we'll do a git push, you'll push it, and we'll create a pull request. So when we create that pull request, then approvers, which is our team, will look at those changes and decide if it's meets our standards, and then that gets merged into the default branch. And then that's when the pipeline should kick in. And the pipeline then goes and runs the basic unit tests that the developer should be running those on their local machine first, and then also run their end-to-end tests. But this will automatically run them, so the whole team can know. And if it fails, we'll get notified via email or Slack that there was a failure. If it passes, it will then continue with the pipeline. It's going to build a container, and then that Docker image, and then it's going to push that to Amazon's image repository. And then it's going to we're going to deploy it to our test environment in Kubernetes. And then that's when we run our end-to-end tests in Playwright and verify that it all works. And if it meets those standards, if it fails, then again, we're going to get notified by the team. And if it passes, it can move to the next deployment, which we have a staging environment. And at some point, right now, it's a manual process to go to production because we do some further testing, manual testing, but you can get it to a point that you could deploy at any point if you're confident in your tests and your quality, that you can do tests. So that's why a lot of people are doing this GitOps type of deployments where you can do quick testing, or even if you want to experiment with the app and do a A/B testing, you could put it out there and test how your users are going to use it, et cetera. So yeah. So the variable, that the goal should be the image. We'd like when we move it, we want to keep the same image. So we have variables in there that will change, like the URL and stuff like that. So we'll pass that in, but the build should be the same. So what typically will happen is you'll do a build and you're going to create a whole bunch of snapshot builds that change all the time. And then when you're pretty confident, okay, we like this, we'll create a release version, which will have a specific number. And what I'm hoping is maybe in the future, we'll go more into some of those details. And then that would go there. And then if it passes there, then you'd release that. And so we never do another build. I mean, we start from the beginning if we have to do.
The URL or something it knows in production? How does the code know that it's production build versus that?
Well, so there's environment variables in the container that would set like what the URL is and the environment it's running in, but the actual code, your Ionic code would be the same. So when we did it in test, that same image would go to QA and that same image would go to prod. So the idea is that we're moving the exact, there shouldn't be any changes in the code base when I release it. And inevitably there's sometimes some problems, but the goal would always be do another build. So we never patch. So the old days, you'd put it in production, find a problem, and then let's do a patch. Now the idea is, especially with containers, we just quickly create a new one with the fix and push it out there. So you're always kind of moving forward.
You go back to that old image while you're creating the new build or the new image with the fix, right? Because you don't want prod down. So is that how you?
Yeah, now, so in this case, and we'll get more of this GitOps, the idea also is that we can do blue-green deployments, that you can deploy it. And rather than the old days, you'd spend an afternoon and take the site down for a Saturday afternoon. This would deploy it, run your QA scripts to verify the deployment's good. And if that's good, it then stays. If it's not good, then it rolls back to the previous release. So that's how it should work. When you get into the databases, it gets a little more complicated based on if you did schema changes and stuff like that. But that's the goal, is to be able to just always be applying new changes and roll back if there's an error. And that's the nice thing with Kubernetes. It makes that a lot easier to do.
Is your app on a native platform, or is it just deployed to the web?
We just do PWA right now. So, yeah, I mean, eventually we'll probably put it in the stores, but right now we're just in testing. It's just the PWA. Again, this is an internal app, so it's really for employees of the company. So we haven't really thought about doing a native one yet. I thought I could do a demo. Do we have enough time? Or are we out of time? How are we doing at time? Okay.
Anybody else have any questions? Raise your hand.
Yeah, put this up for questions because to do the pipeline takes about 5 minutes. So we'll just do a simple pipeline too. We're just going to build we're going to start at the Mongo database and one of the things we were doing that's nice with containers is we can create seed data. So I was working with Clara, and the idea is to come up with some complicated use cases. We're gonna create our seed data like the members and users already. And then what happens is when that gets built, it generates a Mongo image. And so that seed data is refreshed, and then you can run those tests against it. We won't demonstrate the test, but we'll demonstrate the pipeline. So we're just going to do, and here is an example of the pipeline. So this is a Bitbucket pipeline. Starts off where you do your build and test. And then we'll go, oh, this is the wrong branch. Hang on a second here. There we go. I was out of date. Okay, so we'll go into the Mongo seed data. I'm just going to do something simple so I know it's going to work. We'll go in and we're just, this first member is currently Cottonwood. Give me a city here in Utah. Where should we change it? Let's do Provo. Everyone likes Provo. Okay, so just that simple change. I'm going to do,
Just clarify, so if a member went on, well, I'll wait.
okay, let me push this. Okay, so let's go to Bitbucket here. Look at the pipelines. So here was the change, and it kicks this pipeline off. So the first thing this is going to do, so this isn't building the Ionic app. So there's three parts, right? There's the Ionic app, there's a GraphQL Nest.js service, and then there's the Mongo database. The Mongo database actually happens to be part of this GraphQL service. So it's going to go and it's rebuilding the GraphQL service. Didn't really need to, and I probably need to optimize that because the only thing that changed was the Mongo. It does do a conditional that if the seed data didn't change, it won't build a new Mongo image, but it's going to walk through that. So did you have a question, Ryan?
Yeah, I'm good.
So now it's running the Docker build. So this is all done in the cloud on a Ubuntu or Linux image, and actually builds. Bitbucket uses Docker to do the builds, and then so what you're using is a Docker image to actually generate your own Docker images. Yeah.
So the whole build is going on Bitbucket.
Yeah,
In their cloud.
it's in their cloud. Yeah. So if you use something like Jenkins before, that was a pretty popular one that people would use. That would run on-prem, and then you could host your own. But now GitHub has GitHub Actions, which are really powerful too. In some ways, I like them a little bit better than Bitbucket pipelines. But same concept. You can run it all there. It's fairly inexpensive, and you have to deal with all that infrastructure. And then you can set it up so it does an OAuth authentication with your AWS account, because it needs to be able to deploy stuff there. But you want to do it in a secure way.
Are bigger companies using this? You know,
Yeah, lots of companies are using.
like switching from Octopus, and because we're using Jenkins, Octopus, and Circle CI.
Yeah, a lot use different ones. It depends. I mean, Circle CI was a really popular one. I think GitHub and Bitbucket have really come up to speed that it's pretty hard not to do that. I know a lot, like where I work in Salt Lake, they use Jenkins, and most of them are moving away from Jenkins just because Jenkins was powerful, but it had a really clunky user interface, right? Always having to update it. Now you can, like what we use at work is a Kubernetes. We use Kubernetes runners. So because we do a lot of builds that GitHub probably couldn't handle. So you do run, if you do a lot of builds, you have to pay by usage. So you can run out. So we just it ties back into Kubernetes and does the runners within Kubernetes and scales up that way. So that's probably what a lot of companies do here. Okay, so it built, so now it's doing the pipeline to Kubernetes. And so it's going to redeploy all the applications, or at least, well, actually I have it doing all three, even though the one just changed, but. And then the last thing, it sends like a Slack notice. And let me just, I should have brought this up earlier. So this is our Kubernetes cluster. These are the pods that are running. These are the test and staging environments. What I would have shown, what it does is it deletes the deployment. So these test nodes, these test pods would stop, and then it's been recreated. So if I come up here, so it's a brand new instance, so probably needs to refresh. So let's just see if Provo. So it was changed to Provo. So my pipeline worked. Now, what we would add that I need to get, we're working on right now is to run after that step, we would run all the end-to-end tests in Playwright and would verify those kinds of changes. And if Clara came up with some new use cases and we wanted to seed the data with something different or more complicated, like want to get into use cases where you're doing lots of work orders, everything works fine when you've got, a list view of 5 items. But what happens when you have 100 or 1,000? Does it perform pretty well? That's the kind of test that you can do. Yeah.
Do you run your end-to-end test against production?
Not all of them, but I have been using like some Playwright tests to just monitor production. So some of the things that I thought Playwright is really good at is just verifying the application's working, and we can demo some of. Yeah, just walking through and just verifying. So one of the things like with Kubernetes is monitoring the health of your application, but a lot of that is internal. In the end, you might want to do, hey, does it work through the load balancer? And can you log in? And if it doesn't, you should be alerted that the system's down. The other thing that I'm really excited by Playwright, and that's what I wanted to demo it. I'm a big QA person and haven't found, the magic bullet for doing end-to-end testing. Selenium was the popular one, and I've been fighting with Selenium forever. And it's great. It's slow, right? And then when Playwright came out, it's so much faster and so much lighter. So I'm looking at using Playwright and even doing load testing from a UI perspective in like Kubernetes. So you could spin up and simulate hundreds of users hitting your app because they're pretty lightweight, and you could run them in a Kubernetes cluster and do actual load testing from a UI perspective. Playwright also you can do REST API testing and stuff as well. So having kind of one framework to use for testing is just, is fantastic. So yeah, we're really excited about that. So any questions on what we went over? I know we kind of went over, it's a lot of topics. What I've thought, talking with Todd, is maybe in the future, we'd like to come back and present maybe every quarter or every other month or something like that on different topics as we come up. And I don't know if there's topics anyone here is be interested in, but like one of the things we're going to integrate is with Chat GPT. We're going to use, because like most of our workers are Spanish speakers. I'm not a Spanish speaker. My wife is. But translating that and be able to support it in the application, you have both. demoing how we do messaging and social media type of messaging through the app and integrating with the CRM. And then automated device testing. That's always one of the harder ones too, is in the actual device. And then I did talk about performance and load testing, trying that with Playwright. I'm really excited about. And then one thing I want is a kind of a DevOps specific is Argo CD run on Kubernetes. It's an environment, a tool created by Intuit to manage their large Kubernetes clusters. And it's great for development teams that have, when you have to support multiple environments. And from one place, it uses a GitOps type of process where everything's done through Git. So you just, if you check things in and you follow your pull request and have the flow worked out, you can use Git and it will manage all the distributions of your applications. And then also Terraform, if people would like to learn more about Terraform, that's really cool. I don't know. If there's other topics people would like to discuss, just let us know. Yeah. You mean like the console, AWS console versus Terraform? Yeah, if you do anything in cloud, the console, so if you do Google or whatever, they have a nice console, you can go in there and do stuff. I'd always, once you start doing things and want to repeat it, do it all in Terraform. And never go away from that. So one time I tried to upgrade my Kubernetes cluster using the console. That's a bad mistake. Because then I couldn't connect to Kubernetes. I had to tear it down and recreate it and do everything in Terraform. So yeah. I mean, that's a topic actually I think MTech should teach, is a class in Terraform and Terraform. Yeah.
The load testing, you said you were able to do that in Playwright. Performance testing, that wasn't Playwright, right?
Well, I kind of talk about those kind of the same. Performance testing is, how's your application scale with,
How many users are actually?
yeah, and
Okay.
are there slow parts? Load testing is kind of breaking it, right?
Yeah.
Finding the parts that break. So I kind of put them together.
And you're doing all that in Playwright?
Well, I haven't done that yet. That's
So
what,
that's the next step for you.
that's what I'd like to do.
And then how are you handling that now? Or is it just?
Or we're just doing
just
end-to-end
manually
testing. Yeah.
Okay.
I mean, the thing to do with end-to-end testing, and like with the pipeline, most of what you'll see is it's just in the pipeline running one end-to-end test. So
Okay.
it's really just testing functionality, right? So because we have Kubernetes, the thought is we can take that and take those same tests, but now spin them across multiple pods. Instead of running one test, how does my application handle overload tests? And anyone that said, like, one of my first experiences in AWS was a testing application we did for the state of Utah. And we thought we did performance testing until the day they all tested. And that's when we realized we didn't do enough performance testing. So I appreciate that quite a bit. And that's when we moved actually from a MySQL database to DynamoDB, which is a NoSQL database like Firebase, for that very reason. So that's another topic, but here's our contact information. Feel free to contact us. Clara, do you have anything else you want to bring up? Any questions for Clara? I think that's it. Yeah. Thanks.